Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, so let's continue on. Yeah, here determining whether a function is one-to-one. So yeah, some functions have a given output value that correspond to one or more input values. And yeah, for example, they're in the stock chart, so in the figure at the beginning of our chapter, yeah. Maybe let's see if I can show you again. Oh, I'm sorry. Yeah, this one. You see this one? This one. Okay. So here we see that yeah, some in the stock chart shown the stock price was $1,000 on 5 different days, meaning that there were 5 different input values that are receiving the same output value of $1,000. However, some functions have only one input value for each output value, as well as having only one output for each input. And we call this function one-to-one functions. For example, consider a school that uses only letter grades and decimal equivalent. So A for 4, B for 3, C for 2.0, D for 1.0. And the grading system represents a one-to-one function. Okay, because each letter input yields one particular grade point average output, and each grade point average correspond to one input letter. Okay, so the function in part A shows that a relationship is not a one-to-one function because input Q and R both give uh, output N. Okay, I'll show you first the figure that is meant. And the function in part B, so the relationship is one-to-one function because each input is associated with a single which one? Figure one, or this one. Yep, this which one? This one. Okay, you see. So this is one-to-one. This is not one-to-one. Okay. Yeah. Okay. So a one-to-one function is a function in which its output corresponds to exactly one input value. Okay, now let's start. Example 30. Determining whether a relation is one-to-one function. Is the area of a circle function of its radius? Yeah, yeah. A circle of radius r has a unit area measured given by a equals pi r square. Yeah. So for any input r, there is only one output a. So yeah, of course, the area of function is a function of radius r. But this is a function one-to-one. Yeah, yeah. Because if the function is one-to-one, the output value, which is the area, must correspond to a unit input value, is a radius. And any area measure a is given by formula APR square, pi r square. And because there's a radii or positive numbers, that there is exactly one solution. So yeah, this is one-to-one function. So of the circus radius, the area. Okay, now using the vertical line test. Okay, as we have seen some examples above, that we can represent a function is a graph. Okay, so graphs display a great many input output pairs in a small space. Okay, see. And most common graph names the input value x and the output value y, and we say y is a function of x, or y equals fx when the function is named f. Okay. So yeah, the graph of a function is set of all points x, y in this plane that satisfy the equation y equals fx. Yeah. And if the function is defined for only a few input values, then the graph of the function is only a few points where the x coordinate of each point is an input value and y coordinate of each point is a corresponding output value. Okay. For example, let's see figure 7. So f0 is 2 and f6 is 1. And however, the set of all points x, y satisfying y fx is a curve. Okay, so curve so includes 0, 2 and 6, 1 because the curve passes through these points. Okay, so the vertical line test can be used to determine whether a graph represents a function or not. Okay, if we can draw any vertical lines that intersect a graph more than once, then the graph does not define as shown in figure 8. So B and C, a function because function has only one output value for each input value. Okay, so let's see. Which of the graph in figure 9 represents a function y equals fx? Okay, so if any vertical line intersect a graph more than once, then the relationship represented by a graph is a function. You see, A is no problem, B no problem, but as we see, we have two, right? You can see you have two intersections for each input. Okay, so from this we can conclude that these two graphs represent functions A, B, but the third graph, which is a circle, doesn't represent a function because at most x values, a vertical line will intersect the graph at more than one point. Okay, now I'll try this. Okay, as your exercise. Okay, now using the horizontal line test, once we have determined that a graph defines a function, an easy way to determine if it is a one-to-one function is to see the horizontal line test. There you draw lines through a graph. If any horizontal intersect the graph more than once, then the graph does not represent a one-to-one function. Yeah, for example like this. Consider figure 9a and 9b. Okay, the one above. Yeah, this one. Yeah, it's clear for 9a it intersect more than one for some of the value here. Well, fx, I mean, it means that this is not one by one, but for this it is okay. Okay, this is the solution. Okay, you can see. Now identifying basic toolkit functions. Okay. Yeah. Okay. Let's see. Okay, so we have some function. The first function is constant. So constant is just a straight line like this, horizontal line, I mean. For identity, fx equal x is a linear line with slope of 1. Absolute value is the mirror like this. For quadratic, it's very clear. You know how to draw a quadratic one, right? Cubic is like this. Okay, this is just a clip of the graph. Okay, you can plot more than the range shown here. Okay, the reciprocal like this, 1 over x. You see, when it reaches 0 is minus infinity and infinity at the same time. Okay, it's undefined actually. We have reciprocal square. Okay, also it reads something here. And for square root of x it's like this, and cube root of x is like this. Okay, skip, and we enter the discussion on domain and range. Yeah, let's see this data. Okay, top 5 grossing horror movies from years 2000 to 2030, and market share of horror movies by year. Yeah. So yeah, keep in mind that in determining domains and ranges that we need to consider what is physically possible or meaningful in the real world examples such as ticket sales and years in the horror movie example above. Also, we need to consider what is mathematically permitted. Okay. Okay, so we can visualize the domain as a holding area that contains raw materials for function machine, and range as another holding area that the machine products for the machine products. So we can write the domain range in interval notation, which uses value within brackets to describe a set of numbers. Okay, in interval notation that we use square bracket this when the set includes the endpoint, and parenthesis this to indicate the endpoint is either not included or the interval is unbounded. For example, like this: if a person has 100 dollars to spend, then they will need to express the interval that is more than 0 or less than or equal to 100 and write it as shown. So open parenthesis is 0 comma 100, yeah, closing bracket. And we will discuss the notation in greater detail. Actually, we have encountered this before, right? Okay, so yeah, oftentimes they find in the domain of such functions, okay, when the equation is provided, involves remembering three different forms. Okay, first, if the function has no denominator or an odd root, then consider whether the domain could be all real numbers. Second, if there is a denominator in the function's equation, exclude values in the domain that force the denominator to be 0. Third, if there is an even root, consider excluding values that will make the radicand negative. So this is the rule that you need to follow. And here's the summary how to do this. Okay, interval notation. Actually, we have encountered this before. I have in the last chapter, right? You maybe want to take a screenshot on this. Okay, now let's dive into the example. Find the domain of the following function. Yeah, domain is very easy. The first part 2, 3, 4, 5, and 6. Now find the domain of function fx equal x squared minus 1. Okay, so the very important thing here is this: identify any restriction. Is there any restriction? Is there a denominator? No. Okay, so yeah, any real number may be squared and then be lowered by 1. So actually there's no restriction. So the domain is from minus infinity to positive infinity. How about if we encounter fraction? Okay, also the important thing is to identify restriction. Okay, so for the denominator that we set the denominator equal to 0 and so for x, and the function formula contain an even root that set the radicand greater than or equal to 0 and then solve it. Okay, it means that in this way, in this case, 2 minus x is set to be 0, so x equals to 1. So this is the only restriction. Okay, so the interval notation is like shown. Okay, so from minus infinity to 2 and yeah, and 2 to positive infinity. How about if we have an even root like this? Okay, so we need to make sure that exclude any real numbers that result in a negative number. It means that the radicand, in this case 7 minus x, is greater than or equal to 0. Okay, so like this, and x is less than or equal to 7. So this is the solution. Okay, so yeah, as shown. Yeah, in the previous examples, we use inequalities at least to describe the domain of it. We can also use inequalities or other statements that might define sets of value of data to describe the behavior of a variable in set builder notation. Okay, for example, like this. Okay, let me continue explain a little again. So yeah, I think you have see this before. Yeah, this is easy, right? So there are three types. So how we express a function, okay? So we can create an inequality notation. We can create using a set builder notation, and also we can create it using an interval notation. Okay, so yeah, as I pointed out here, it's very clear that we can combine two intervals using inequality notation or set builder notation or the use of OR. So this is the symbol for OR, union symbol. Okay, like this, you can see. Okay, so set builder notation is a method of specifying a set of elements that satisfy a certain condition. It takes the form of this x statement about x, which is right, the set of all x statement about x is true, for example, like this. And type of notation is a way of describing sets that include all real numbers between a lower limit that may or may not be included and an upper limit that may or may not be included, and the endpoint values are listed between brackets or parentheses. For example, like this. They're given a line graph that describes the set of values using interval values, interval notation by following these 4 steps. So for example, like this, the first range, it is what? You see, this is a black dot, so it means 1 greater than, less than equals x, less than equals 3. Okay, okay. And the second range is that, you see, this is a blank dot, so 5 less than x, less than infinity. And we use union as notation. This. Oh yeah, one more. For infinity, you can never use a bracket. Okay, you only use parentheses. Now finding domain and range from graphs. Another way to identify the domain arrays of function is by using graph. Okay. Yeah. So okay, I think this is for this time. Yeah, I want to show you first, yeah, a little code before I end. Okay, so change the word by being yourself. This is for Amy Polar. Yeah, that is all for today. Thanks for watching. Subscribe, give a like, comment
That's
about
the
your
end of the
thoughts, share this
video for
video to
today.
your friend.
Thanks for
I'll be back
watching.
on
Thanks for
every
following so far. I'm
Tuesday.
curious what you
Okay,
need to do.
thank you
Please
for watching
subscribe,
and see you in the
give a
next
thumbs
episode.
up,
Goodbye.
comment,